reliable network. Network must support a wide range of applications and services as well as operate over many different types of cables and devices, which makes which make up the physical infrastructure. The term network architecture in this context refers to the technologies that support the infrastructure and the program services and rules or protocols that move messages across the network. As network evolve, we are discovering that there are four basic characteristics that underlying architecture need, need to address in order to meet user expectations. Fault tolerance, scalability, quality of service, and security. Fault tolerance. The expectation in that is that the internet is always available to the millions of users who rely on it. This requires a network architecture that is built to be fault tolerant. A fault tolerant network is one that limits the impact of a failure, so that the fewest number of devices are affected by it. It is also built in a way that allows quick recovery when such a failure occurs. These networks depend on multiple paths between the source and destination of a message. If one path fails, the message can be instantly sent over a different link. Having multiple paths to a destination is known as redundancy. Circuit switched connection-oriented networks. To understand the need for redundancy, we can look at how early telephone systems worked. When a person made a call using a traditional telephone set, the call first went through a setup process. This process identified the telephone switching locations between the person making the call, the source, and the phone set receiving the call, the destination. The temporary path or circuit was created for the duration of the telephone call. If any link or device in the circuit failed, the call was dropped. To reconnect, a new call had to be made with a new circuit. This connection process is referred to as a circuit switch process and is illustrated in the figure. Many circuit switch networks give priority to existing circuit connection at the expense of new circuit requests. After a circuit is established, even if no communication is occurring between the persons on either end of the call, the circuit remains connected and resources used until one of the parties disconnects the call. Because there are only so many circuits that can be created, it is possible to get a message that call circuits are busy and a call cannot be placed. The cost to create many alternate paths with enough capacity to support a large number of simultaneous circuits and the technologies necessary to dynamically recreate drop circuits in the event of failure is why circuit switch technology was not optimal for the internet. Packet switched networks. In the search for a network that was more fault tolerant, the early internet designers researched packet switched network. The premise for this type of network is that a single message can be broken into multiple message blocks with each message block containing addressing information to indicate the origination point and final destination. Using this embedded information, this message block called packet can be sent through the network along various paths and can be reassembled in the original message when reaching their destination, as illustrated in the figure. The devices within the network itself are typically unaware of the content of the individual packets. Only visible are the addresses of both the source and the final destination. These addresses are often referred to as IP addresses, represented in a dotted decimal format such as 10.10.10.10. Each packet is sent independently from one location to another. At each location, a routing decision is made as to which path to use to forward the packet toward its final destination. This would be like writing a long message to a friend using 10 postcards. Each postcard has the destination address of the recipient. As the postcards are forwarded through the postal system, the destination address is used to determine the next path that postcard should take. Eventually, they will be delivered to the address on the postcards. If a previously used path is no longer available, the routing function can dynamically choose the next best available path. Because the messages are sent in pieces rather than as a single complete message, the few packets they may be lost can be retransmitted to the destination along a different path. In many cases, the destination device is unaware that any failure or rerouting occurred. Using our postcard analogy, if one of the postcards is lost along the way, only that postcards need to be mailed again. The need for a single, reserved circuit from end to end does not exist in a packet switch network. Any piece of a message can be sent through the network using available path. Additionally, packets containing pieces of messages from different sources can travel the network at the same time by providing a method to dynamically use redundant paths without intervention by the user. The internet has become a fault-tolerant method of communication. In our mail analogy, as our postcard travel through the postal system, they will share transportation with other postcards, letters, and packages. For example, one of the postcards may be placed on the airplane along with lots of other packages and letters that are being transported toward their final destination. Although packet switch connectionless networks are the primary infrastructure for today's internet, there are some benefits to a connection-oriented system like the circuit switch telephone system. Because resources at the various switching locations are dedicated to providing a finite number of circuits, the quality and consistency of messages transmitted across a connection-oriented network can be guaranteed. Another benefit is that the provider of the service can charge the user of the network for the period of time that the connection is active. The ability to charge users for active connections through the network is a fundamental premise for the telecommunication service industry. Scalability. Thousands of new users and service providers connect to the internet each week. In order for the internet to support this rapid amount of growth, it must be scalable. A scalable network can expand quickly to support new users and applications without impacting the performance of the service being delivered to existing users. The figures show the structure of the internet. The fact that the internet is able to expand at the rate that it is without seriously impacting the performance experienced by individual users is a function of the design of protocols and underlying technologies on which it is built. The internet has a hierarchical layered structure for addressing, for naming, and for connectivity services. As a result, network traffic that is destined for local or regional services does not need to traverse to a central point for destination. Common services can be duplicated in different regions, thereby keeping traffic of the higher level backbone networks. Scalability also refers to the ability to accept new products and applications. Although there is no single organization that regulates the internet, the many individual networks that provide internet connectivity cooperate to follow accepted standards and protocols. The adherence to standards enables the manufacturers of hardware and software to concentrate on product development and improvements in the areas of performance and capacity, knowing that the new product can integrate with and enhance the existing infrastructure. The current internet architecture, while highly scalable, may not always be able to keep up with the pace of user demand. New protocols and addressing structures are under development to meet the increasing rate at which internet applications and services are being added. Quality of service. Quality of service (QoS) is also an ever-increasing requirement of networks today. New applications available to users over internet networks, such as voice and live video transmissions, as shown in Figure 1, create higher expectation for the quality of the delivered services. Have you ever tried to watch a video with constant breaks and pauses? Network must provide predictable, measurable, and at times guaranteed services. The packet switch network architecture does not guarantee that all packets that compromise a particular message will arrive on time, in their correct order, or even that they will arrive at all. Networks also need mechanisms to manage congested network traffic. Network bandwidth is the measure of the data carrying capacity of the network. In other words, how much information can be transmitted within a specific amount of time. Network bandwidth is measured in the number of bits that can be transmitted in a single second, or bits per second (bps). When simultaneous communications are attempted across the network, the demand for network bandwidth can exceed its availability, creating network congestion. The network simply has more bits to transmit than what the bandwidth of the communication channel can deliver. In most cases, when the volume of packets is greater than what can be transmitted across the network, devices queue or hold the packets in memory until resources become available to transmit them, as shown in Figure 2. Queuing packet causes delay because new packets cannot be transmitted until previous packets have been processed. If the number of packets to be queued continues to increase, the memory queues fill up and packets are dropped. Achieving the required QoS by managing the delay and packet loss parameters on network became the secret to a successful end-to-end application quality solution. One way this can be accomplished in through classification. To create QoS classifications of data, we use a combination of communication characteristics and the relative importance assigned to the application, as shown in Figure 3. We then treat all data within the same classification according to the same rules. For example, communication that is real-time sensitive, such as voice transmission, would be classified differently from communication that can tolerate delays, such as file transfers. Examples of priority decisions for an organization might include time-sensitive communication, increased priority for services like telephony or video distribution, non-time sensitive communication, decreased priority for web page retrieval or email, high importance to organization, increased priority for production control or business transaction data, undesirable communication, decreased priority or block unwanted activity like peer-to-peer file sharing or live entertainment. Security. The Internet has evolved from a tightly controlled internetwork of educational and government organizations to a widely accessible means for transmission of business and personal communication. As a result, the security requirements of the network have changed. The network infrastructure services and the data contained on the network-attached devices are crucial personal and business assets. Compromising the integrity of these assets could have serious consequences such as network outages that prevent communications and transactions from occurring with consequent loss of business. Intellectual property research ideas, patents, or designs that is stolen and used by a competitor. Personal or private information that is compromised or made public without the user's consent. Misdirection and loss of personal or business funds. Loss of important data that takes a significant labor to replace or is irreplaceable. There are two types of network security concerns that must be addressed: network infrastructure security and information security. Securing a network infrastructures include the physical securing of devices that provide network connectivity and preventing unauthorized access to the management software that resides on them. Information security refers to protecting the information contained within the packets being transmitted over the network and the information stored on the network attached devices. Security measures taken in a network should prevent unauthorized disclosure, prevent theft of information, prevent unauthorized modification of information, prevent denial of service. In, in order to achieve the goals of network security, there are three primary requirements as shown in Figure 2. Ensuring confidentiality. Data confidentiality means that only the intended and authorized recipients, individuals, processes, or devices can access and read data. This is accomplished by having a strong system for user authentication, enforcing passwords that are difficult to guess, and requiring users to change them frequently. Encrypting data so that only intended recipient can read it. It is also part of confidentiality. Maintaining communication integrity. Data integrity means having the assurance that the information has not been altered in transmission from origin to destination. Data integrity can be compromised when information has been corrupted, willfully or accidentally. Data integrity is made possible by requiring validation of the sender as well as using mechanisms to validate that the packet has not changed during transmission. Ensuring availability. Availability means having the assurance of timely and reliable access to data service or authorized users. Network firewall devices, along with desktop and server antivirus software, can ensure system reliability and the robustness to detect, repel, and cope with such attacks. Building fully redundant network infrastructure with few single point of failures can reduce the impact of these threats. Okay, activity network architecture requirements. Select the appropriate column to identify the network architecture requirement to which each characteristics or feature belongs. Network should always be available. Fault tolerance. Full memory quits means packets must be dropped. Quality of service. Priority queues are implemented when demand for network bandwidth exceeds supply. Again, quality of service. Business and personal network equipment must be protected. That's about security. Business and personal network equipment must be protected. Sorry, I'm reading the same question. Sorry. Developing a plan for priority queuing is a strategy for quality delivery of information. Developing a plan for priority queuing is a strategy for quality delivery of information. It can be quality of service. Business and personal data must be protected. Different types of internet service providers can affect the quality of network data delivery. Fault tolerance. Network can grow or expand with minimal impact on performance. Scalability. Priority for queuing packets is based on the type of data sent and how important it may be. Quality of service. Data can travel through more than one route for delivery from a remote source. Fault tolerance. Type of network equipment, how they are identified, and how they are named can have impact on the growth of the network. Scalability. Many tools and procedures are being implemented to address the need to exchange confidential and business critical information. Security. Traffic delay and data loss should be considered when setting up delivery to a priority queuing. Traffic delay and data loss should be done when setting delivery to a priority. Compromising the integrity of crucial business information. Business and personal assets could have serious repercussions. Don't know what does that mean. Common network standards allow hardware and software vendors to focus on product improvement and services. Let's say scalability. Types of network connectivity can affect delivery of information. Types of network connectivity can affect delivery of information. Check. Fine. Network trends. What do we have here? And how much should I suffer? Networking technologies for the home, network security, network architecture. Okay, when you look at how the internet has changed so many of the things people do daily, it is hard to believe that it has only been around or for most people for about 20 years. It has truly transformed the way individuals and organizations communicate. For example, before the internet became so widely available, organizations and small businesses largely relied on print marketing to make consumers aware of their products. It was difficult for businesses to determine which households were potential customers, so businesses relied on mass print marketing programs. These programs were expensive and varied in effectiveness. Compare that to how consumers are reached today. Most businesses have an internet presence where consumers can learn about their products, read reviews from other consumers, and order products directly from the website. Social networking sites partner with businesses to promote products and services. Bloggers partner with businesses to highlight and endorse products and services. Most of this product replacement is targeted to the potential consumer rather than the masses. Figure 1 shows several predictions for the internet in the near future. By 2014, traffic from wireless devices will exceed traffic from wired devices. By 2015, the amount of the content traveling the internet annually will be 540,000 times the amount of that traveled in 2003. By 2015, 90% of all content on the internet will be video based. By 2015, a million video minutes will traverse the internet every second. By 2016, the annual global IP traffic will surpass the zettabyte threshold. By 2016, the number of devices connected to IP networks will be nearly 3 times as high as the global population. By 2016, 1.2 million minutes of video content will cross the network every second. By 2020, 50 billion devices will be connected to the internet. As new technologies and end user devices come to market, businesses and consumers must continue to adjust to their ever changing environment. The role of network is transforming to enable the connections of people, devices and information. There are several new networking trends that will affect organizations and consumers. Some of top trends include any device to any content anyway, online collaboration, video and cloud computing. These trends are interconnected and will continue to build off of one another in the coming years. The next couple of topics will cover these trends in more detail. But keep in mind, new trends are being dreamed up and engineered every day. How do you think the internet will change the next 10 years, 20 years? Figure 2 is a video that shows some of Cisco's thoughts on future development.
The world's about to change. 95% of everything we know as a species will be discovered in the next 50 years. This applies to medicine, physics, biology, in fact, just about every major discipline. There is a technology avalanche on the horizon that will profoundly change how we work, live, play, and learn. My name is Dave Evans, Cisco's Chief Futurist and the Chief Technologist for Cisco's Internet Business Solutions Group. As we think about the future, we at Cisco wanted to add another perspective to the conversation and perhaps inspire you to think differently about the world and in turn financial services.
concept of any device to any content in any way is a major global trend that requires significant changes to the way devices are used. This trend is known as bring your own device. Build is about end users having the freedom to use personal tools to access information and communicate across a business or campus network. With the growth of consumer devices and the related drop in cost, employees and students can be expected to have some of the most advanced computing and networking tools for personal use. These personal tools include laptops, netbooks, tablets, smartphones, and e-readers. These can be devices purchased by the company or school, purchased by the individual, or both. Beyond means any device with any ownership used anywhere. For example, in the past, a student who needed to access to campus network for or the internet had to use one of the school's computers. These devices were typically limited and seen as tools only for work done in the classroom or in the library. Extended connectivity through mobile remote access to the campus network gives students tremendous flexibility and more learning opportunities for the students. Beyond is an influential trend that has or will touch every IT organization. Online collaboration. Individuals want to connect to the network not only for access to data applications but also to collaborate with one another. Collaboration is defined as the act of working with another or others on a joint project. For business, collaboration is a critical strategic priority. To remain competitive, organizations must answer three primary collaboration questions. How can they get everyone on the same page? With decreased budget and personnel, how can they balance resources to be in more places at once? How can they maintain face-to-face relationships? Sorry. How can they maintain face-to-face relationships with a growing network or colleagues, colleagues, customers, partners, and peers in an environment that is more dependent on 24-hour connectivity? Collaboration is also a priority in education. Students need to collaborate to assist each other in learning, to develop the skills used in the workforce, and to work together on team-based projects. One way to answer these questions and meet these demands in today's environment is through online collaboration tools. In traditional workspace and with built environments alike, individuals are taking advantages of voice, video, and conferencing services in collaboration effort. The ability to collaborate online is changing business processes. New and expanding collaboration tools allow individuals to quickly and easily collaborate regardless of physical location. Organizations have much more flexibility in the way they are organized. Individuals are no longer restricted to physical locations. Expect knowledge is easier to access than ever before. Expansion in collaboration allow organizations to improve their information gathering, information and productivity. The figure lists some of the benefits of online collaboration. I will not read this, guys. You can read it by yourself. Collaboration tools give employees, students, teachers, customers, and partners a way to introduce, connect, interact, and conduct business through whatever communication channels they prefer and achieve their objectives. Video communication. Another trend in networking that is critical in the communication and collaboration effort is video. Video is being used for communications, collaborations, and entertainment. Video calls are becoming more popular, facilitating communications as part of the human network. Video calls can be made to and from anywhere with an internet connection, including from home or at work. Video calls and video conferencing is proving particularly powerful for sales processes and for doing business. Video is a useful tool for conducting business at a distance, both locally and globally. Today, businesses are using video to transform the way they do business. Video help businesses create a competitive advantage, lower cost, and reduce the impact on the environment by reducing the need travel. Figure 1 shows the trend of video in communication. Both consumers and businesses are driving this change. Video is becoming a key requirement for effective collaboration as organizations extend across geographic and cultural boundaries. Video uses now demand the ability to view any content on any device anywhere. Businesses are also recognizing the role of video to enhance the human network. The growth of media and the new uses to which it is being put is driving the need to integrate audio and video into many forms of communication. The audio conference will coexist with the video conference. Collaboration tools designed to link distributed employees will integrate desktop video to bring teams closer together. There are many drivers and benefits for including a strategy for using video. Each organization is unique. The exact mix and nature of the drivers for adopting video will vary from organization to organization and by business function. Marketing, for example, may focus on globalization and fast changing consumer tastes, while the Chief Information Officer CIO focus may be on cost saving by reducing travel costs of employees needing to meet face to face. Figure 2 lists some of the drives for organizations to develop and implement a video solution strategy. Figure 3 is a video that gives a closer look at how the telepresence using video can be incorporated into everyday life and business. Other trend in video is video on demand and streaming live video. Delivering video over the network lets us see movies and television programs when we want and where we want.
I would like to thank you all for joining us. Cisco Telepresence powers the new way of working, where everyone, everywhere can be more productive through face-to-face collaboration.
Cloud computing. Cloud computing is the use of computing resources, hardware, and software that are delivered as a service over the network. A company uses the hardware and software in the cloud, and service fee is charged. Local computers no longer have to do all the heavy lifting when it comes to running network applications. The network of computers that make up the cloud handles them instead. The hardware and software requirements of the user are decreased. The user's computer must interface with the cloud using software, which may be a web browser, and the cloud network takes care of the rest. Cloud computing is another global trend changing the way we access and store data. Cloud computing encompasses any subscription based or pay per use service in real time over the internet. Cloud computing allows us to store personal files, even backup our entire hard disk drive on servers over the internet. Applications such as word processing and photo editing can access using the cloud. For businesses, cloud computing extends IT's capabilities without requiring investments in new infrastructure, training new personnel, or licensing new software. These services are available on demand and delivered economically to any device anywhere in the world without compromising security or function. The term cloud computing really refers to web-based computing. Online banking, online retail stores, and online music downloading are all examples of cloud computing. Cloud applications are usually delivered to the user through a web browser. Users do not need to have any software installed on their end device. This allows many different kind of devices to connect to the cloud. Cloud computing offers the following potential benefits. Organizational flexibility. Users can access the information anytime and any place using web browser. Agility and rapid development. IT department can focus on delivering the tools to mine, analyze, and share the information and knowledge from databases, files, and people. Reduced cost of infrastructure. Technology is moved from one side to a cloud provider, eliminating the cost of hardware and applications. Refocus of IT resources. Cost saving of hardware and applications can be applied elsewhere. Creation of new business models. Applications and resources are easily accessible, so companies can react quickly to customer needs. This helps them set strategies to promote innovation while potentially entering new markets. There are four primary types of clouds, are shown in figure 2. Cloud computing is possible because of data centers. Data centers is a facility used to house computer systems and associated components, including redundant data communications connections, high-speed virtual servers, sometimes referred to as a server farm or server clusters. Redundant storage systems typically uses sun technology. Redundant or backup power supplies. Environmental controls, e.g. air conditioning, fire suppression. Security devices. Data center can occupy one room of a building, one or more floors, or an entire building. Modern data centers make use of cloud computing and virtualization to effectively handle large data transactions. Virtualization is the creation of virtual versions of something, such as a hardware platform, operating system, storage device, or network resources. While a physical computer is an actual discrete device, a virtual machine consists of a set of files and programs running on the actual physical system. Unlike multitasking, which involves running several programs on the same OS, virtualization runs several different OSs in parallel on a single CPU. This drastically reduces administrative and cost overheads. Data centers are typically very expensive to build and maintain. For this reason, only large organizations use privately built data centers to house their data and provide services to users. For example, a large hospital may own a separate data center where patients' records and mentioned electronically. Smaller organizations that cannot afford to maintain their own private data center can reduce the overall cost of ownership by leasing server and storage services from a larger data center or organization in the cloud. The figure is video about the growing use of cloud computing and data center services. Networking technologies for the home. Networking trends are not only affecting the way we communicate at work and at school, they are also changing just about every aspect of the home. Newest home trends include smart home technology. Smart home technology is technology that integrated into everyday applications, allowing them to interconnect with other devices, making them more smart or automated. For example, imagine being able to prepare a dish and place in it in the oven for cooking prior to leaving the house for the day. Imagine if the oven was aware of the dish is was cooking and was connected to your calendar of events so that it could determine what time you should be available to eat and adjust start time and length of cooking accordingly. It could even adjust cooking times and temperatures based on changes in schedule. Additionally, a smartphone or tablet connection allows the user the ability to connect to oven directly to make any desired adjustment when the dish is available. The oven sends an alert message to specified end user device that the dish is done and warming. This scenario is not long off. In fact, smart home technology is currently being developed for all rooms within a house. Smart home technology will become more of a reality as home networking and high-speed internet technology becomes more widespread in homes. Now, home networking technologies are being developed daily to meet these types of growing technology needs. Networking technologies for the home. Powerline networking is an emerging trend for home networking that uses existing electrical wiring to connect devices as shown in the figure. The concept of no new wires means the ability to connect the device to the network wherever there is an electrical outlet. This saves the cost of installing data cables and without any additional cost to the electrical bill. Using the same wiring that delivers electricity power line, networking sends information by sending data on the certain frequencies similar to the same technology used for DSL. Using a home plug standard power line adapter, devices can connect to the LAN wherever there is an electrical outlet. Powerline networking is especially useful when wireless aspect points cannot be used or cannot reach all the devices in the home. Powerline networking is not designed to be a substitute for dedicated cabling or for data networks. However, it is an alternative when data network cables or wireless communications are not viable option. Wireless broadband. Connecting the Connecting to the internet is vital in smart home technology. DSL and cable are common technologies used to connect homes and small businesses to the internet. However, wireless may be another option in many areas. Wireless internet service providers WISP, wireless internet service provider is an ISP that connects subscribers to the designated access point or hotspot using similar wireless technologies found in home wireless local area networks (VLANs). VISPs are more commonly found in rural environments where DSL or cable services are not available. Although a separate transmission tower may be installed for the antenna, it is common that the antenna is attached to an existing elevated structure such as water tower or radio tower. A small dish or antenna is installed on the subscriber's roof in range of the YSP transmitter. The subscriber's access unit is connected to the wired network inside the home. From the perspective of the home user, that setup isn't much different than DSL or cable service. The main difference is that connection from the home to the ISP is wireless instead of physical cable. Wireless broadband service. Another wireless solution for the home and small businesses is wireless broadband. This uses the same cellular technology used to access the internet with a smartphone or tablet. An antenna is installed outside the house providing either wireless or wired connectivity for devices in the home. In many areas, home wireless broadband is competing directly with DSL and cable services. Network security. Network security is an integral part of computer networking, regardless of whether the network is limited to a home environment with a single connection to the internet or as large as a corporation with thousands of users. The network security implemented must take into account the environment as well as the tools and requirements of network. It must be able to secure data while still allowing the quality of service that is expected of the network. Securing a network involves protocols, technologies, devices, tools, and techniques to secure data mitigate threats. Many external network security threats today are spread over the internet. The most common external threats to network include viruses, worms and Trojan horses, malicious software and arbitrary code running on the user device, spyware and adware. Spyware installed on a user device that security collects information about the user. Zero-day attacks, also called zero-hour attacks. An attack that occurs on the first day that the vulnerability becomes known. Hacker attacks, an attack by a knowledgeable person to use user devices or network resources. Denial of service attacks, designed to slow or crash applications and processes on the network device. Data interception and theft, my favorite one. An attack to capture private information from an organization's network. Identified theft, an attack that steals the login credentials or a user in order to access private data. It is equally important to consider internal threats. There have been many studies that show that the most common data breaches happen because of internal users of the network. This can be attributed to lost or stolen devices, accidental misuse by employees, and in the business environment, even malicious employees. With the evolving beyond strategies, corporate data is much more vulnerable. Therefore, when developing a security policy, it is important to address both external and internal security threats. No single solution can protect the network from the variety of threats that exist. For this reason, security should be implemented in multiple layers using more than one security solution. If one security component fails to identify and protect the network, others still stand. A home network security implementation is usually rather basic. It is generally implemented on the connecting host devices, as well as the point of connection to the internet, and can even rely on contracted service from the ISP. Contracted services from the ISP. In contrast, the network security implementation for corporate network usually consists of many components built into the network to monitor and filter traffic. Ideally, all components work together, which minimizes maintenance and improves security. Network security components for a home or small office network should include, at the minimum, antivirus and anti-spyware to protect user devices from malicious software, firewall filtering to block unauthorized access to the network. This may include a host-based firewall system that is implemented to prevent unauthorized access to the host device, or basic filtering service on the home router to prevent unauthorized access from the outside world into the network. In addition to the above, larger networks and corporate networks often have other security requirements. Dedicated firewall systems to provide more advanced firewall capability that can filter large amount of traffic with more granularity. Granularity. Access control lists (ACLs) to further filter access and traffic forwarding. Intrusion prevention systems (IPS) to identify fast spreading threats such as zero-day or zero-hour attacks. Virtual private networks (VPN) to provide secure access to remote workers. Network security requirements must take into account the network environment as well as the various applications and computing requirements. Both home environment and businesses must be able to secure their data while still allowing the quality of service that is expected of each technology. Additionally, the security solution implemented must be adaptable to the growing and changing trends of network. The study of network security threats or mitigation techniques start with a clear understanding of the underlying switching and routing infrastructure used to organize network services. Firewall. An attack which slows down. This is a DOS attack. Filters network access and data traffic. Block unauthorized access to your network. Network attack that occurs on the first day that vulnerable stability becomes known. Arbitrary code check. Network architectures. The role of the network has changed from data-only network to a system that enables the connections of people, devices, and information in a media-rich, converged network environment. In order for networks to function effectively, efficiently, and grow in this type of environment, the network must be built upon a standard network architecture. The network architecture refers to the devices, connections, and products that are integrated to support the necessary technologies and applications. A well-planned network technology architecture helps ensure the connection of any device across any combination of networks. While ensuring connectivity, it is also increases efficiency by integrating network security and management, and improves business processes. At the foundation of all network architectures, and in fact at the foundations of internet itself, are routers and switches. Routers and switches transport data, voice, and video communications, and as well as allow or for wireless access and provide for security. Building networks that support our needs of today and the needs and trends of the future starts with a clear understanding of the underlying switching and routing infrastructure. After a basic routing and switching network infrastructure is built, individuals, small businesses, and organizations can grow their network over time, adding features and functionality in an integrated solution. As the use of these integrated expanding networks increase, so does the need for training for individuals who implement and manage network solutions. This training must begin with the routing and switching foundation. Achieving Cisco Certified Network Associate certification is the first step in helping an individual prepare for a career in networking. CCNA certification validates an individual's ability to install, configure, operate, and troubleshoot medium-sized route and switch networks, including implementation and verification. Sorry. Sorry. CCNA validate individuals' ability to install, configure, operate, and troubleshoot medium-sized route switch network, including implementation and verification of connections to remote sites in a WAN. CCNA curriculum also includes basic mitigation of security threats, information to wireless networking concepts and terminology, and performance-based skills. This CCNA curriculum includes the use of various protocols such as IP, OSPF, Serial Line Interface Protocol, Frame Relay, VLANs, Ethernet Access Control Lists, and others. This course helps set the stage for networking concepts and basic routing and switching configuration, and is a start on your path for CCNA certification. You will research job opportunities, reflect, and research. This is interesting. I hope you will not miss this lab and the summary. The summary. Try your concept of the internet now. In this activity you will use, well, this is an activity, so guys, I hope you will do this on your own. Okay, this is the summary, and we are this chapter. Okay, you will read, or you can miss this as you wish. Okay guys, thank you for watching. Leave your feedback, leave your feedback, like, subscribe for more videos, and don't forget to comment this video and